Welcome to this demo on IBM Watson Openscale. The IBM Watson Openscale helps you monitor the machine learning models. In this demo, we'll be monitoring a credit risk model. A credit risk model is designed to predict whether someone is eligible for a loan. Historically, a variety of parameters such as credit history, age, number of dependents, etc. were used to decide whether a particular person should be given a loan. However, now, because of the market demand, credit lenders are under pressure to provide loans to wide variety of customers. At the same time, try to reduce the risk. So they are now relying on new type of data, for example, utility payments, online purchasing behavior, and other kinds of data. They are also creating complex machine learning models that can predict the outcome of a loan. Now, these models cannot be black boxes. For regulatory as well as business reasons, lenders need to understand why their risk model makes a specific decision for an individual applicant. They need to make sure that their models are not operating with bias for specific groups. Let us see how Watson OpenScale can provide insight into the credit risk model. So let's go to the main screen of Watson OpenScale here. So I am in the inside dashboard. Here I am monitoring multiple versions of the same credit risk model. One of the model is in production, and I have two other models which are in pre-production and approved and pre-production. So I can see that there are some alerts that are coming from this model, and there are basically three parameters that are being monitored. One is the quality of the model, there's the fairness of the model, and the third one is the drift on the model. Right? Now these alerts indicate that the model is not fair, so there is a bias in the model. So let's look at the fairness of the model. So as the chart shows, we have set up a model fairness threshold score of 98%. When the model score becomes less than 98%, we say that the model is biased. The model, of course, is plotted every hour for over a week. Now, the monitored aspects of this fairness are age and sex for this model, but we can add other parameters to be monitored. But we are only monitoring age and sex in this model. So if we see the green line, it's the average fairness score of the model, showing that it is much lesser than the threshold score, which indicates that the model is biased. So let's look at more details of this. So here it shows that males received a favorable outcome of 49% and females received a favorable outcomes of 38%. This kind of indicates that the model fairness score, which is basically the ratio of two positive outcomes, which is 38 by 49, which is approximately 77.6%. So that's how we get the fairness score of 77.6%. The model, as I explained earlier, is biased because our threshold of model fairness score is 98%. Now this is based on the balanced data set. We can actually look at other data sets. For example, there is a payload data set, there is a training data set, and as well as there is a debiased data set. So let's look at the training data set. So it shows, the training data set shows that there has been a lot more number of records for males versus females. That means there were more applicants that applied for a loan than female applicants. There's also these debiased endpoints where we see what was done by Watson Openscale is to replace our monitored feature whenever there was a negative outcome uh, by uh, uh, by by a reference parameter. So, for example, if the loan was rejected, we kept all other parameters same and just replaced female with male and seen whether the model predicts otherwise. If it predicted otherwise, that means the model was biased. This unbiased endpoint can be accessed by applications. Now, what we can do is we can drill down into these transactions and look at the details of these transactions. So here it shows the various transactions that shows the group biases as well as the individual biases and what was the outcome of the prediction. So let's look at this monitored outcome, whereas here it says the loan application was rejected uh, um, with a confidence score of 84.3%. So let's look at the explainability of this transaction. Watson Openscale identifies all the positively and negatively correlated parameters and also the weight that the model used to predict the outcome of the prediction or the outcome of the result. So here it says that top 3 features influencing the model's predicted outcomes are sex, loan amount, and loan duration. The top 3 features, others on loan, customer resident duration, as well as the age. So these were negatively correlated features. Now I can go ahead and inspect this transaction and see here. So these are the features that participated in the outcome of the prediction of the model. Now what we want to do is we want to find out if if I change, one of the, if can I change some attributes so that I receive a different outcome for the model prediction. So here the model was predicting risk with a score of 84.3%, whereas here it shows that there is no risk with 61.98%. So this transaction is biased because I just replaced female to male with all the other parameters being the same. So for a female, the loan was rejected, whereas for a male, the loan was approved, the rest with all the other components being the same. So we say that model is biased. So what we just saw is that how Watson Openscale provides you aggregated transactions, bias indications, as well as explainability of those transactions um, and the various features that contributed for the outcome of that for that model predictions. Now let's go back to the main dashboard and try to understand the drift. Let me click on the drift. Drift is basically when the model loses the accuracy or the model falls in accuracy because of a different data that is coming in production than what it was trained initially. So here we can set up a threshold of accuracy, and then we can monitor the accuracy of the model in the runtime and compare it with the accuracy of the model in the runtime. So the model so the base accuracy is defined as the accuracy of model in the training time, and the estimated accuracy is the model accuracy of the model in the runtime. So so the estimated accuracy minus the difference of the estimated accuracy and base accuracy gives us the drift accuracy. Now we can actually go ahead and look at the details of this drift. Now drift is caused because of three different reasons here. We identify that there is a drop in accuracy because of um, because of various parameters, and we show these parameters. For example, here the drop in accuracy was because of primarily the age being a primary factor. This could mean that the model was trained with a particular age group in mind, but then when the model encountered a different group, it started behaving differently. So we can actually go into these transactions in detail. Again, we see that the see the all the parameters are shown, like age, loan duration, loan amount, credits paid, less than one, employment duration, and this. And then we can actually ask Watson Openscale to predict or to explain this prediction, how it termed this as a risky customer. So here it shows that there were top influences of this transactions were risk, where whether the person owns the property, whether the person has a credit history, what was the sex of the person, and whether he was paying installments. So these are some of the positive influences of the model. So one of the greatest influencers um, being whether the customer owns the property, credit history, and the sex. So what we saw is that with Watson Openscale, we can monitor the machine learning models that are running with different machine learning providers. These could be Azure ML or Amazon SageMaker or other machine learning providers. We are using Watson Openscale. We are able to monitor for biasness. We are able to detect the quality as well as drift. We are also able to explain the transactions of the model, even though the model was completely a black box to us. This concludes the demo of Watson Openscale. Thank you.